The James Webb Space Telescope has just sent Earth a massive warning, and it's getting closer. This warning comes from the exoplanet Proxima b. With each new image sent back, more questions arise, leaving authorities terrified. Each snapshot from this distant planet makes us wonder more about the mysteries of the universe. Growing questions are arising about a potential enemy planet near Earth. Could there be a neighboring alien planet that has hostile intentions? Could Proxima b pose a threat to our very existence? The question of alien life has intrigued humanity for centuries, but with modern technology like the James Webb Space Telescope, it has become a question we can explore more thoroughly than ever before. Yet, the universe isn't making it easy to find answers. We continue to use our best tools, such as the James Webb Telescope, to capture glimpses of distant planets and galaxies, hoping to find clues that might hint at life beyond Earth. Let's be realistic, though. Every new image and piece of data mostly serves to remind us of how little we actually know. While these discoveries could be groundbreaking, they also highlight the vastness and complexity of the cosmos, leaving us with more questions than answers. Understanding a far-off planet like Proxima b could redefine our place in the universe. For scientists in astrophysics, this is thrilling, but for the general public, it often feels like just another piece of space news, distant, abstract, and sometimes overwhelming. These revelations raise more questions than they answer, leading many to wonder what this means for life on Earth. Could Proxima b really harbor life or even intelligent life that might one day pose a threat to us? Despite the immense power of the James Webb Space Telescope, it can only show us so much. Sure, we've learned some incredible things, like the fact that we now have stunning new images of Proxima b, and we know that the universe is even bigger than we ever imagined. But what comes next? The practical implications of these discoveries can feel as vast as the universe itself. Proxima b, discovered in 2013 due to its gravitational interaction with its star, was a major scientific breakthrough. For many scientists, finding this exoplanet was like discovering a new cosmic neighbor. Proxima b is just slightly larger than Earth, and it orbits its star every 11 days, making it an intriguing subject for further exploration. From a scientific perspective, the idea of another world so close to ours is exhilarating. Yet, for most people, it's hard to connect with a place that's 25 light-years away. To put that into perspective, even the fastest spacecraft humans have ever created would take tens of thousands of years to reach it. Imagine what it would be like to stand on Proxima b. Its star, Proxima Centauri, would appear as a big, dim red light in the sky, much cooler and darker than our sun. Proxima b orbits so quickly that a year there lasts just over a week. One side of the planet always faces the star, meaning it is locked in perpetual daylight, while the other side is shrouded in endless night. It sounds like something out of a science fiction novel, but the reality would be far more brutal. On the bright side of Proxima b, any water would likely boil into steam due to constant exposure to heat. On the dark side, however, the water would freeze into solid ice. The planet's star, Proxima Centauri, is also not a calm and steady neighbor like our sun. It throws out dangerous flares and intense radiation, making the surface of Proxima be a hazardous place for life as we know it. This isn't exactly the kind of neighborhood where humans would want to set up camp. Interest in finding life beyond Earth hit a peak in late 2020 when scientists detected an unusual signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had a unique frequency of 982.551 MHz, which caught everyone's attention. Such a signal could, in theory, be an indication of advanced technology, though it is far too soon to draw any conclusions. More recently, the James Webb Space Telescope fueled even more excitement by suggesting that Proxima b might have water vapor in its atmosphere. Water, as we know, is a fundamental ingredient for life, and its presence could be a game changer. To better understand how much water is present on Proxima b, scientists are employing advanced techniques like spectroscopy. This method allows them to detect the gases that surround the planet, acting like a high-tech detective tool. By analyzing the planet's light spectrum, scientists can identify specific gases such as oxygen, methane, and carbon dioxide, all of which are essential for life. Atmospheric modeling is another key approach. By using computer simulations of Proxima b's atmosphere, scientists can make educated guesses about its conditions. These models serve a similar purpose to how paleontologists use dinosaur bones to reconstruct what dinosaurs might have looked like. However, the more we learn about Proxima B's atmosphere, the more we are reminded of the incredible diversity of life forms that exist here on Earth. Extremophiles, for instance, are tiny organisms that can survive in extreme conditions, boiling hot springs, acidic lakes, and the freezing cold of Antarctica. These resilient creatures demonstrate that life can adapt and thrive under conditions once thought impossible. Could life on Proxima B be equally adaptable? The pursuit of life on Proxima B presents enormous challenges, not just in terms of space travel, but in proving that life can exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere might not offer much protection. Additionally, the distances involved are so immense that new types of propulsion systems are necessary to make space travel to Proxima B feasible. Concepts like solar sails, ion propulsion, and even more theoretical ideas like warp drives offer exciting possibilities for future exploration. However, these technologies are still in their infancy and require extensive research before they can be used in real missions. While dreaming about future space travel is thrilling, we need to remain realistic. Discovering life on Proxima B is fraught with technological and scientific challenges. Only by advancing our technology and deepening our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima B. This pursuit is not merely about satisfying curiosity. It's about pushing the boundaries of human achievement. Could we one day set foot on Proxima B or even make contact with life there? As we consider the long journey to Proxima Centauri, the idea of finding aliens no longer feels confined to the realm of science fiction but instead seems like a real, tangible possibility. This exciting shift from a distant dream to a scientific endeavor has attracted serious attention from cutting-edge organizations like Breakthrough Initiatives. These groups are dedicating immense resources to transforming what would typically be an impossibly long journey, one that could take tens of thousands of years using today's technology, into a mission achievable within a few decades. The goal of reaching another star system within a human lifetime has sparked innovation and optimism in the scientific community. However, these grand ambitions are quickly tempered by the stark realities of our current technological limitations. Despite remarkable advancements in space exploration, the idea of traveling to Proxima Centauri, even at 4.2 light-years away, still presents daunting challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey feasible in any reasonable time frame. Breakthrough Starshot, one of the most notable projects, envisions using powerful laser-driven sails to propel tiny spacecraft to speeds up to 20% the speed of light. While this concept shows promise, it's still in the experimental stage and requires overcoming numerous technological and logistical hurdles, such as minimizing damage from space debris and ensuring accurate long-distance communication. While the dream of reaching Proxima Centauri and potentially discovering alien life is closer to reality than ever before, it remains grounded by the constraints of present-day technology. Accelerating a spacecraft to near the speed of light with today's tools feels almost impossible, like trying to solve a difficult puzzle in the dark. Even bold projects like Starshot, which aims to propel a spacecraft toward Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere creates disturbances for the lasers, making it difficult for space exploration tools to function with the precision required. One suggested solution is the use of adaptive optics, smaller lasers on satellites that continuously monitor and adjust for atmospheric disturbances. This system would help powerful ground-based lasers remain focused on spacecraft as they travel through space. However, the laser propulsion technique demands an enormous amount of energy, equivalent to the total energy consumed by the entire United States, and it would only work for a short period. Imagine setting up 100 million lasers over a vast area just to push a small spacecraft, only 33 feet wide, to 20% of the speed of light. At this speed, the spacecraft would still take 22 years to reach the Alpha Centauri system, a time frame longer than many people's lifetimes. But the challenge of reaching Alpha Centauri isn't solely about overcoming technical obstacles. There are natural barriers as well. The gravity of the sun, the presence of space debris, and the sheer vastness of the distance involved all pose significant risks. Even communicating with a spacecraft en route to Proxima b would feel like sending messages through time. It would take about 4 years for a signal to reach it from Earth. Despite these daunting challenges, the desire to explore other star systems continues to grow. It's driven by humanity's deep-rooted love for discovery and exploration, rather than practical necessity. Even bold projects like Starshot, which aims to shoot a spacecraft toward Alpha Centauri using lasers, face many practical challenges. However, solving these problems could revolutionize space exploration. Still, the potential risks involved, including communication delays and natural hazards, require thorough planning. Despite the difficulties, many scientists believe that the rewards far outweigh the risks. The idea of discovering life on Proxima b, or another distant exoplanet, continues to captivate imaginations worldwide. Discovering life on another planet would be the most profound discovery in human history. While there is still much work to be done before we can travel to distant stars, the pace of technological advancements and our growing understanding of the universe give hope that this dream could become a reality. Until then, we will continue to rely on the James Webb Space Telescope and other advanced tools to gather clues from afar. In the meantime, whether Proxima b will be a beacon of hope for future generations or a warning of potential dangers from beyond remains an open question. The journey to explore this mysterious exoplanet is just beginning, and the next chapter of our cosmic adventure awaits. Only time will tell what discoveries lie ahead in the endless expanse of space.